Okay, I said, you are now empowered to create your own UIs. Almost. We haven't seen how to do graphics, which is the most interesting part of your UI, which is the main UI, right? We've seen how we can take sliders, progress bars, menu items, and all compose them together. And these things are called components, okay? I call them widgets, but they're also called components because there's this class called component that unites them all together. And these components are painting or drawing graphics for us. Okay, so the slider really drew a rectangle in a window. Okay, the text field drew some text in a window. Ultimately, they're all painters. Okay, so we know how to go and use components, these widgets that do the painting for us, but we don't know how to paint ourselves. Okay, and that is what we need if we really want to be totally independent of Object Editor. So let's go and look at something Object Editor produced for us. So when I introduced to you composite objects, I took this Cartesian plane as an example, and I had some object that had a y-axis, an x-axis, an x-label, a y-label. It had another property called axis length, and that's a model that we created, and the view got created for us magically as long as we followed certain conventions. Okay, and now we want to know what we can do ourselves. And what we create is not going to be very, given the models we have, given that the lines are of a certain length and a certain position, and we can't do very much different, okay? But we can do it ourselves. That's a big deal. And we can be a little different. You don't have to worry about the visible prop annotation in the model. You can just not show the axis length because you're in control now. It's not as this general tool that doesn't know what you want, so you have to go and tell it what you want. Now you can build your custom tool and just do whatever you want to, okay? So where it had this particular two components to this frame, we're just going to have one component, okay? No hide draw panel. Where it drew black solid lines, we'll draw dashed lines and blue. Where it drew black labels, we drew blue labels. Not that that's better, but it's just as different, okay? So we want to do that now. How to do it? And we don't want to give up on Object Editor. So if something changes in one view, we want it to change in the other view too. And that is what MVC was created for. Two views showing you the same model simultaneously. And this could also be, two different users, in fact. Okay? So this is what we want to happen. And how should we make this happen? Well, we've got a model and we can just have to create another view. Everything else is in place. We just have to know how to create this particular view. Okay, so let's begin slowly here. We know we've got a frame. Anything that we can move around on the screen, with this X and any window on the screen is a frame. So we know we have a frame. Earlier in the frame we had, a button and a text field. Okay. Or maybe a menu bar and a menu item. What should go under my frame now? We don't know what the classes of these objects may be, but first tell me how many widgets does a frame have inside it? 0, 1, 2, 10. Austin? 1. Okay. And why not 2? You don't see any, you would see 2 widgets then. Okay, so there's probably 0 or 1. We don't know. It could be the frame itself, or it could be a component that covers the whole frame. Okay? It's one of these 2 answers, and one's a good answer. Okay? So earlier we had text field or buttons. We had some of these adjectives. Okay? This is a text field. This is a widget. The widget is the general name, which is totally non-descriptive. And text field is descriptive name. Okay, button is a descriptive name. What kind of descriptive name would you give to this one component? Canvas, excellent. Okay, actually Java has something called canvas. I don't know what it does. Okay, but ultimately, it's just a widget. Any of these things, text field, buttons, they're all just widgets in which you can draw. And when I say it's a widget, which is sort of what the technical, I mean, what the general term is, that really means it's a component. It's a subclass of something that's ultimately a component. And there is a class called canvas that's a subclass of component. I don't know what it gives you over component. Okay? But a component will suffice for us because a component really is a canvas. Okay? That's a good name for it. And any widget is a canvas. It just so happens a text field is a canvas filled by the text field programmer, and a button is a canvas filled by the button programmer. And this is a canvas we have to fill. Okay? So that's it. Our logical structure, our structure of this UI is pretty simple. Okay? So the next thing is, how do we go and draw on this canvas? Okay? So far what you guys did was you created these line objects and so forth, and object editor drew for you. And drawing really means going to the frame buffer and setting pixels. Okay? Now, we don't want to set pixels, right? We don't want to figure out how to set pixels in the thing. So hopefully Java gives us something to set the pixels. And we can just say, draw line, draw rectangle, draw oval, and it'll draw the pixels. Okay? So we want these methods to be called. We want to just say draw line, draw oval. So draw oval would be called on what object? On the canvas. Okay. So you might have, okay, I guess I'm trying to, so before I go to that, I want to make the point that we are going to show multiple properties in this one canvas. Okay. So we're going to have a Cartesian plane has got an int, which is the, actually the int we won't show, well, which is the axis length. But it's got a line, another line, a shape, another shape. All of them will be mapped to this one component. Okay? Which is what these lines say. Okay? And this is the dual of the situation. Multiple properties in one component. It's not as if I'm going to have my height be displayed in one text field and my weight be displayed in another text field. I'm going to show them all in one canvas. Okay? Go to the situation where I had my BMI value being shown in two different widgets. Okay, that's my slider and progress bar, that we were talking about. And it was shown, if my BMI was really high, I'd be, off the scale here, or this particular thing would be off here. So this is the dual of that situation. Okay? And so that's what's happening here. And now we come up with the API. Okay? So you called it a canvas. And if you call it a canvas, it must have canvas-like methods, which could be draw string, draw oval, draw line, draw rectangle. I think it's rect, I hope. Okay, draw image. And this is a draws. And what do you think fill oval would be? You'd fill it with some color. Okay? So what does object editor do? Object editor says, if you've got the filled method in your Boolean property in your object, I will call fill oval. Otherwise, I'll call draw oval, if you're an oval. Okay? So object editor is doing that, and now you can just call these methods. And this is something that I'm sure a lot of you have actually, some of you who've used this stuff have already seen. Okay? Everybody fine with this? Okay? Those of you who've actually used graphics, you should not be fine with this. How many of you have drawn graphic shapes in a canvas, in a window? Are you fine with this? You shouldn't be fine with this. This is a lie. Yeah. You're not okay with it, or you're okay with it? And if you're not okay with it, you've got to tell me why you're not okay with it. So it's dangerous to say no. Austin? I haven't given the parameters. Yes, I haven't given the parameters. I'll give you those later. But you can. They're the obvious parameters. They're not so obvious for the line. Line takes 2 endpoints. Okay, whereas this will fill line takes 2 endpoints. Whereas in object editor I take a width and height, which is probably confusing. This is not what happens. This is a total lie. Yeah. Okay, so there are a lot of questions I haven't answered, and that's what you're getting to. Good. I haven't told you what the parameters are, and I haven't told you when you fill what color it is, and that is now an interesting thing. So how do you think the color is picked up of the oval when you do fill oval? It's not an argument to fill oval, as it turns out. You don't take a color as an argument. You say fill or don't fill. Fill oval and draw oval take the same arguments. In one case you fill, in one case you don't fill. So somehow the color is there. Okay. What did you say? Graphics object? Did I hear somebody say that? Zach, did you say that? No. Somebody else said that. Fred? No. Okay, somehow. But Zach, you were going to say something? Predetermined, but you should be, but how would you draw blue versus red? We need some way. So it might be a property of component, right? And now we get into an issue. Indeed, component has a property. And you can make it green or blue or, the Carolina blue or your own different blue. But that's what that's what object editor does. It makes it Carolina blue. But I want to draw white on Carolina blue. So I don't want to use the color of my component. I want the color of the pen. I want not only a canvas, but I want a pen that goes and paints on the canvas. I need an object to represent a pen in a canvas, not a canvas. And that pen I can go and say, this is your color, this is your stroke. Are you blue? Are you green? Are you dashed? Are you not dashed? That is not a property of component. That is my pen's property. And that doesn't make sense in component. Okay? It makes sense. I still don't know who said graphics object, but it makes sense in another kind of object. And before I get to that, Frank, you had a question?
I was just thinking, so you said that the pen is not a property of the component?
No, I'm saying the color and stroke are not properties of components. The pen may be.
Right. Oh, okay.
But we need a separate object now.
Right.
We can't just have component be the pen also.
Okay.
They are conceptually two different things.
Right.
Okay, so we are drawing with a pen. Okay. And we say, okay, I've filled red ink into this. Filled ink. That seems so quaint, right? Anybody used a fountain pen here? 3 of you have. Okay. I've broken many nibs. Nib? Quaint term also. Okay. So that's what we're going to have. Okay. And we are going to, so need some object that encapsulates a component and a pen. Okay? And that is called a graphics context in general. Okay? And it happens to be called a graphics object in Java. Okay? It's a context. So you always paint within some context. So Windows systems, called it, there was a Windows system called X that was a very influential system, and that invented the term graphics context. And now these methods are not in component, but they are in graphics. And now it makes sense to have a color for the pen that is separate from the color of the window. Okay? And we can have a get stroke, a set stroke, and so forth. And, Java couldn't make up its mind what the graphics object should really be. And so it first had a graphics object. And actually, I'm not sure the set stroke is here. And then it created something called a graphics 2D object. And for compatibility reasons, it sort of had to use graphics 2D. You need to do some casting, which we'll see later. So I've shown draw 3D rect as a method here, but I have a feeling that set stroke may also be here. I forget. These are details, and I can only remember so much. Okay, so that's my pen. Okay, and nothing very profound here. In fact, a lot of books that when Java came by, a lot of books started off as almost the first assignment as one in which people drew circles. They said, here's some code, just change this code and don't worry about the context, and it'll all work. Okay, and that's how they did it. And so drawing these lines is conceptually not hard. Understanding the framework is somewhat hard. Okay? Questions? Okay, and just to make it very concrete, here I've got a paint method that by magic gets a graphics object as an argument. And once it gets an argument, it goes and casts the graphics object to graphics 2D, just in case it's going to use some methods the graphics 2D has. And it says, okay, I'm setting the stroke to dotted, whatever that means. Okay, that is some object. I'm setting the color to blue. And so I've gone and filled the appropriate ink in it. Okay, now I'm going to draw it, and I'm doing this modularly. I go and say draw, using this graphics context, which is a component plus a pen, the Cartesian plane. And I'm going to say, okay, I've got a draw method that draws a label. I've got a draw method that draws a line. So I'm just going to call for the labels, the label method, for the lines, the line method. Okay, this is the kind of code you'll write now. Okay. Okay. So that's the code. Now we get into some architectural issues. So this paint method I've shown you without showing you what class it is in. Okay? And we know that we're using MVC. Okay? So we've got models, we've got to create our views and controllers. Here we don't need a controller because we're not doing any input. We're just displaying things. We'll let object editor's controller be used to go and change the axis length, for instance. Okay? So this paint method must then be in which class? We've got two choices. We've got no controller. The view. Okay? This is what view really means, right? View in the text box is not as exciting as view in graphics, perhaps. So this paint method must be in the view. Okay? Now is the more important question, which is also not going to be hard. So this paint method is called when? This paint method in the view should be called when the model changed. So whenever a notification is received, whenever the update method is called. Okay, good. Can I rename the paint method to draw, perhaps? Austin? Okay. So the issue is not paint or draw. The issue is whether this is a method signature given to me, or a signature that I can invent, which is what you're getting into. And you're saying if I made a draw, then maybe this is a signature that was given to me. And if signature was given to me, why was it given to me? Why couldn't I just have my own signature? So why can't I call it draw, output, whatever? In other words, yeah. Okay, so your object editor has told you that your freedom is taken away from you. Okay, it says, hey, I'm your collaborator. I happen to be a program, and I'm dumb, so you have to go and tell me what you're up to, right? Now you're free of object editor. This is you can do whatever you want to. So you're free of object editor, but you're not completely free because you're calling these draw methods. You're using these graphics objects. So you're never completely free as long as you don't build on top of machine language. Okay. So what dependency do you have on not object editor, but whoever's drawing things for you? Which is answered by this question, really. How did my view get a graphics object? It got a component. How did it get a graphics object? Well, you might think that the component has a get graphics object in it. No, it doesn't. Okay, that's something that's created by the system, okay, for various reasons. So somehow it has to get a graphics object. Somehow somebody has to go and give it a graphics object. If somebody has to give it a graphics object, somebody has to sort of call a method in us to give it a graphics object, and that method better have a certain signature. Okay? So this graphics object is not something that is peculiar to a component, and it's created on the fly, and every time you paint or repaint it, you might get a different graphics object. Okay? So it's not something that's a static property of the component. So we have to follow a signature, and somebody has to call a paint method in us so that we get the graphics object. Okay? This is sort of one of the tricky issues here. Okay? And we'll try to understand why this is happening in a few slides properly. Okay? So these are all questions that arise when you write something like this. These are all questions that people in 101 don't answer, which is what we're going to answer. Okay? And to answer that question, I'm going to ask another question. Okay? So we've drawn our pretty picture, and we also happen to have created a BMI spreadsheet UI, and we go and put the BMI spreadsheet on top of our pretty picture, which means what? Our first pretty picture is only partially shown, which means what? Some of the pixels in the frame buffer have been overwritten with the pixels of this picture. Okay, that's what happens. Okay, and now we say we want to see our graphics picture, so we go and unobscure it, we expose it, so these pixels have to be redrawn. Okay, the question is, who does the redrawing? Does our code do the redrawing? Or does the system, the window manager? The window manager is the one we are using to put one window on top of another window, to unobscure the window, to expose the window, to unexpose the window. Is the window manager redrawing the pixels for us? Or is our code redrawing? What do you guys think? Zach?
The window manager?
You would think that we always want not to do work, right? So the system has the information. The system knows exactly this particular portion of the screen got obscured. It knows that now this window is there. It could just create a copy of those pixels in memory, and whenever you go and expose an obscured area, it could go and copy back the pixels. Why make us do it? That's an excellent answer, and systems people would love to do that. And as it turns out, and what other answer could be? The programmer. So could there be any reason why we don't do it that way and we make the programmer redraw it? Okay, so there are two problems with the system doing things. Firstly, it had to go and copy all these pixels, right? Which means it takes memory, and this frame buffer takes memory. And the second thing is that while the picture was obscured, you guys do a lot of animation. It could have changed, in which case it's drawing stale data. It's not showing current data. Okay? So in fact, people have gone back and forth on this. When I say this is a question and it's got a clear answer, historically it's not had a clear answer. People have gone Zach's approach first and then gone your approach. And nowadays I think they sort of give you an option. From what I remember the last time I studied this stuff was that there's some Boolean you set and either the system saves it or you go and redraw it. Okay? So we have to be ready to redraw it. Just in case the window manager's options have been set that way. Given that we have to redraw it, and you have to redraw it for the following reason. If you might have noticed that when your application stops running, when your PowerPoint or Word just go into some loop, you go and cover the window, you uncover it, what do you see? A black screen. That's because that application has just gone into nowhere land. And it's not really doing anything, it can't redraw things for you. So these black areas that you see happen because the window manager just goes and puts nothing in there, it clears the area, and the area has not been redrawn on by the application code. Okay? Given that is the case, somehow the window manager and the application code have to communicate with each other now. Okay? The application code is there, it can redraw, and it has to be able to redraw. And somehow the window manager has to tell the application, please redraw. Okay? And how am I to tell that? We've seen many examples of this, right? That somehow an application component has to be told some information by the system component. And I said, when the application calls a method in the system component, we call it a call. When a system component calls something in the application, we call it a callback. Somehow we need a callback. Okay? And we need something to happen. And there's many ways to do it. Who repaints the window? Window manager application. It is, and the answer comes from the fact that while the component was unexposed, the drawing might have changed. So in general, the application must redraw it. And the question is, how does the application know it should redraw? And again, those of you who've done painting before, do you want to venture a guess, or anybody else want to venture a guess as to exactly how the application is told about it? Okay, let me ask you another question. Maybe this will help. So clearly, whenever a property changes, whenever our model changes, we have to redraw, right? And also, when the model first got connected to us, we have to draw, and we have to draw when the window gets unexposed. How can we combine all these three things into one method? So we just have one method that gets called in all three conditions. And we saw that method just a while ago. And that method we know now must be called in reaction to a system component, which means it must have a standard signature. I'm just taking a lot of time to tell you why it has a standard signature. I can just tell you it has a standard signature. Don't ask me why, right? I'm telling you exactly why it does. That somehow you have to follow some standards if you want to make the same method draw for the first time, draw when the model changes, draw when the window is exposed. And now we see the control flow. What happens exactly is that the window manager says everything is finally a component. I know that. Everything is derived from a component. And what I will do is assume I will call the repaint method in the component, saying, please redraw yourself. Okay? In component, the repaint method says, I will manufacture a graphics object, and I will go and pass that graphics object to my paint method, which follows a certain signature. That's a protocol. Okay? That's the protocol between the window manager and the component. The protocol between the window manager and the component is it calls repaint. That's the protocol. And the further protocol that is developed by component is that whenever repaint is called, it will call paint with a manufactured graphics object. Okay? But now the paint method has to be called not in component. The component is just going to draw maybe its background. But we really want the paint method to be called in our view. Right? Because we want to draw the axes, we want to draw the text label. So how does the paint method that is called in the component result in a paint method that is called in our view? That's the next question. And how does a callback, we know how a callback occurs in a component in reaction to the window manager. Okay, window manager came first, the component came next, so the window manager invoked a callback in the component. Now we need a callback from the component to our view. And how could we do it? This is the same question I asked you when I said, when a button is pressed, how is a callback invoked on my controller? It's a similar question. And what was the answer for the button? So when the button is pressed, we just went through this earlier, right? Event, and that event is sent as a notification. Okay? So we could have a notification sent, and anything else we could do? Keenan, do you remember your solution to the button problem? Sorry? The controller was a button. Okay? So the window manager calls repaint, it calls paint, and paint occurs when a component is uncovered. So this is what I just said earlier. And now the question is how to make application view redraw graphics and component. There are two ways to do it, and this is the Keenan way now. Okay? We will make our view a subclass of component. Okay? and we will redefine the paint method. Okay. So what's going to happen? When repaint is called, repaint always calls the component's paint method. And now when a repaint method is called in the superclass, it says, I'm going to call paint graphics on the object, and I'm going to use the most specific paint graphics there is. And the most specific paint graphics there is our paint. Okay? So our paint will be called rather than the paint of component, which draws the background. Now, if we want the background to be redrawn, our paint should call the paint in the superclass. Okay? And that's how it all works out. Okay? That's basically, I've told you everything. Okay? And we just write this one paint method. You've already seen that. It happens to be in the view. And it's called, if the model changes, when the model changes, we'll call repaint. We'll see that. But it's called every time things have to be redrawn. So we didn't really have to do extra work to redraw an exposed area. Yeah, the system can go and copy things into a pixel, into a pixel object, a buffer. But we've already got the paint method which we can just call again and again, and we don't have to go and store any pixels. We don't have to be space inefficient. This paint method just keeps getting called again and again. Okay, questions? You guys, so from a software engineering point of view, is this a good solution? Is the ISA being used properly? So I'm just saying I'm just showing the property. When the property change event is called, is the view conceptually a component? Okay. So there were some extra things there, but we basically said the Cartesian plane view is a component. Okay, and that, a view has a component. It's not a component. Okay, so I told you people get it wrong. Okay, smart people get it wrong. And we know that this is not the case because when we create and look at the two different hats we have to put. When our view is a displayer of graphics, it is a component. When our view uses a predefined widget, it has that widget. It has the component. Okay, so it's just confusing. Okay, and also similarly for the same arguments, a controller is not a component. A controller has a component. But fortunately, when we're using Java 1.1 at least, a controller has a button. So there's all these different things going on here, and things were more unified when 1.0 was around, because then the controller also had to be a component. The way you intercepted events from components at that time was through ISA, and now into 1.1 they moved to the has a, but they didn't move completely. Okay, and I've been waiting for a toolkit that did it right, and in fact, so input and output events intercepted through ISA in 1.0, and your Eclipse environment has a different toolkit. It's called SWT, and it actually allows you to have the Cartesian plane have a reference to component. The component just goes and is an observable, and whenever it's paint, I think that's how it happens, but that's how I would do it if I was doing it. The component just registers observers with it, and you can register your view as an observer and say, whenever your paint method is called, let me know, give me the graphics context, and then the view can draw things. Okay, that's how they should have done it. That's how they didn't do it. Okay, they did it partly, but not completely. Okay. So you will have to face this kind of confusion, but that's the way things work. Okay, questions? So we are not using SWT, so we have to go back to this. We have to go to the first picture I showed you, and let's just see how this all works together. So the Cartesian plane is something we'd seen earlier. It is an observable. We are not going to change it. We are using model view controller. I've just got this code for you to reference and not go back. This is also, and my Cartesian plane view now. This is the interesting part. Extends component, okay, which is the ugly part here. it is a view. It implements a property change listener. And because it extends component and it wants to override the paint method, it must say paint graphics G. It can't say draw graphics G or something else. Okay? And whenever property change is called, it goes and calls repaint. And repaint will go and it can't call paint directly because it doesn't know what the graphics context is. That is manufactured by the component. And that repaint will call paint with graphics. And now all the things I said earlier happen now in this paint method. Okay? Questions? And that one is going to do
and this is reproduced.
Again, it's going to subdivide and say, okay, let's go and write a routine that draws a line. Let's write another method that draws a label. Let me go and pass the X label and Y label to the methods that draw labels. Let me pass the X line, the two lines to this guy. And these guys just go and call the draw line and the draw string method I showed you. Okay, no, nothing difficult here. I mean, people teach introductory programming with this kind of paint method. They don't quite tell them how the paint method is called. They say just take an applet, subclass it, write your paint method, and that's it. Okay? And people do a lot of looping and other things with such a paint method. Okay? So this is it. And this is my composer. And my composer now is adding my view now is a Cartesian plane view. Okay, that's my component, and I'm putting the view into the frame. Okay, so I'm putting my frame view into the frame, which makes me shirk, you know. But that's what you're doing. So you take your view and put it as a component into the frame, and that's how you compose the UI. Okay, so that's the code that's your complete UI code. And in your next assignment, I'm going to ask you to go and display your bridge scene using your own view. Okay, you've already got a view that registers itself as a listener for all the properties of your scene. Okay, it just prints the property. It just prints all those properties on the console. Now your property change event. Now your view is going to just call repaint, and you're going to have a paint method that goes and draws all those components. Okay. Okay. And how exactly we haven't seen how to draw images, okay. So let's go and see that quickly. I'm going to now do a plotted shuttle, where the plotted shuttle is the plotted shuttle we saw earlier. So we have now a plane on a plane, as somebody told me once, and we have the shuttle on top here, and we want to draw our own custom view without all these text fields that goes and draws the shuttle in the plane. Okay, and we already have code to go and draw this plane. So we'd like to be able to reuse that code to draw this, right?
Which I don't want to go back to because I'll lose my recording.
So we already had some code for the model,
so we have to all
and we reuse that model code to create the model code with the shuttle. Okay, so we've already done reuse of the model. We want to now do reuse of the. Okay.
And because it was being used for both input and output, both our view and controller had links to it. Okay. So when our view got the event, it did not go and change the text. Sorry, when our controller got the event, it did not go and change the text. It just said, let me go and change the model. Okay? So it never even did get text because the action event has enough information to go and tell it what the text was. Okay? But it could have done a get text. There's no harm in doing that if the event did not give that information. Okay? And it went and changed the model. The model changed the view. And the view came back and changed the text. Okay? So the view and controller were separated, and one was conceptually reading the text, and the other one was conceptually writing to the text. Just as the model gets written to by the controller and gets read by the view. Okay? So the view is the consumer of the information from the model and the producer of the information into the text field. The controller is the consumer of the information from the text field and the producer of information into the model. So there's all these interesting dualities here. Yeah.
For that particular example, is it kind of unnecessary to, let you get back the information to text? Because like the text, that text has already been changed.
Yeah, so that's what I said. I said that, that's a redundant change. But if there were multiple views,
Okay? And if you want to keep all the views consistent, and the model doesn't know which view the information, which controller the information came from, which UI the information came from. So the model goes and says, hey, here's a new value for everybody. Okay? And whoever doesn't need the new value will say, oh, my text is the same as what I'm getting, so I won't even make the change. Okay? So the view could have done the check. The text field can do the check. The model cannot do the check if there's more than one view. That's what I was trying to say. Answer your questions? Okay. So let's try to do a new problem. Okay. And now we have a plotted shuttle. And if you remember, the plotted shuttle was designed by having a shuttle, by having a Cartesian plane as one of the properties of the plotted shuttle, and having another, that's what we see here. The Cartesian plane is one of the properties, and shuttle x and shuttle y are two other properties that are added by plotted shuttle. Okay? And I might want not only the object editor user interface, but I might also want my own user interface. Okay, in my own user interface, I don't have to go, I just get rid of the text fields. Okay? I just have the view, and I'm going to again use the dotted lines here. So if I was to just do this, given that we have a Cartesian way to display the Cartesian plane, what kind of objects might I create for this plotted shuttle to display this? Do I need a controller? So I've already got the model. I'm not going to change the model. Okay? We have to worry about the controller and the view. Do I need a controller? My right user interface is the manual one. Okay? So, do I need a controller? Is there any input here? No controller. Okay? So I need a view. The view should be a subclass of something that is a paint method. Okay? Should I make it a subclass of component, or can I do better? JFrame is just a container for the whole thing. Okay, so we're going to put the component in the JFrame. So I can make it a subclass of component, just as I made my Cartesian plane view a subclass of component. But I can do better than that if I want to reuse code. I'll make it a subclass of a Cartesian plane view. Okay, because I want to reuse the code. Okay? Now conceptually, that view should have a link to that other view. Okay? Just as my model has a link to that. But we are constrained by what Java has done for us. Okay? So we make it a subclass of that, and our paint method will do what? It has to draw the Cartesian plane, and it has to draw the shuttle. So how will it draw the Cartesian plane? Called super.paint. And then it will go and draw the shuttle on top. Okay? So that's pretty straightforward. Okay, we're just subclassing one from the other. Okay? So nothing new has to be learned to do that.
Because of the, so again, you know,
okay,
we want both views to be
now we have the views consistent.
And we'll
so
add some more.
Change the shuttle x, shuttle y, and both shuttles. Okay, so that's
we'll
nice.
add some new angles also.
That was what model view control.
Whenever the mouse clicks, we'll go and
keeping in sync. Okay. Now let's add some interesting things here. I'm going to click in the plotted shuttle window, mouse click. So I'm going to add some input. So we'll now need a controller. Okay. And when the mouse
reset the shuttle. Okay. So now we have to go and listen to the mouse clicks also. Whenever we click on the window and make the click and focus it, whenever we focus a window, we can type characters that are listened to by the window. So whenever we make the window the focus window by just selecting the window, if we go and type X in the X direction to some predefined position, okay, so it listens to the X event. And if we type Y, we'll make it go find
it goes
Y
to some
position.
preset.
So we have to somehow listen to keyboard events.
So I've already added myself with the mouse listener. Now and I've got a mouse controller.
That's our task.
Now I want what kind of listener? Key listener of some kind. And I have a key controller. Let's keep these controllers separate. We can have one controller for everything, but why should these controllers know about each other? They don't need to. You can remove one controller to go and disable key events. You can remove another controller to disable mouse events. Okay? That's why you might want multiple controllers. Okay? So after I did the MVC lecture, one student came to me and said, I think it was you, can you have multiple controllers? And here's an example for why you might want multiple controllers.
And how do we do this? Well, we still have a component. It's the same, it's a similar kind of structure, but my component now we want is and it's got to be a specialized component so that it can redraw the view, and to draw the Cartesian plane view. Okay, so what I will do now is create another component that draws the plotted shuttle view, which is a subclass of Cartesian plane view. Okay, just as Cartesian plane view was a subclass of component, my plotted shuttle view will be a subclass of Cartesian plane view. Okay, same idea being applied a second time, and we're going to have key typed and mouse clicked be methods that have to be somehow listened to by the controllers, and we're going to have just the observer pattern used for these to happen. So we're going to have two controllers, a key controller and a mouse controller, and they're going to, and a component is going to have, it does have methods to register these controllers. Okay, so we had seen that in text field it could register events, it could register observers for the action event. So whenever we pressed a button, a method callback could be invoked on our controller. Now the same idea is being applied here, except we register not for the button click, which is a very button specific thing, but a mouse click or a key being typed. So we make the mouse controller either we got two controllers. The mouse controller is a mouse listener, and the key controller is the key listener. Okay, again, this is just the observer pattern being used again and again. Okay, so when the key is pressed, the key type method is called in the key controller, which goes and sets a shuttle, which goes and says property changed, which goes and results in repaint being called in the component method, which results in the paint method being called, the most specific paint method being called, super types paint method, and which results in get Cartesian plane being shown. So this is the same idea is being applied in a bigger scale. Okay, and you get the shuttle image now, and click. And I just want to show you this code, and I've managed to do all this little quickly. I'll go through this again next time again, but I want you guys to get started on your project this week. Okay, otherwise I have no project to give you guys. Okay, the one issue is, how do you go and draw images? Okay, and my plotted shuttle view, as I told you, is a subclass of a Cartesian plane view, and which happens to be a subclass of the component. And here is where we see how to go and draw an image. Okay, that is the code I really wanted to show you. So my paint method called super paint. My super paint happens to be the paint in my Cartesian plane displayer, and it then goes and says draw something extra over what your superclass drew. Okay, so your superclass drew the plane, and now this draw method goes and takes an image. It goes and gets the image file name, image object. Okay, the shuttle image object that you guys have seen earlier. Okay, and from that it goes and gets the image file name, and the image file name it gives to some magical routine, which returns some magical object called image, which can be passed to draw image, and you can go and say, please draw the image at this X and this Y. Okay, so we have to somehow convert a file name into something that we can pass to our canvas, to our graphics object. That graphics object has got a draw image. It takes some magical argument, which we don't care about, but we want to draw it at a certain position. So from our image, we get that X and Y. We pass ourselves to it. Why we do it, we don't care about this. That's some magic. Okay, it's just in case there's some kind of error, we need to pass ourselves to it. And the main point is that you need to convert a file name into image object, and this is what does it. And now you understand the whole theory behind drawing this. In the recitation, you will get some code that will actually exercise this stuff, which you can morph, knowing this theory, to go and draw your scene. Okay, so your next project essentially says, please replace your observer with another observer that draws the scene, and it's not going to be hard, because you see, even though all this interaction I showed you was complex, doing the work. Because of division of labor, you just say, do whatever my super paint does, and I'll do the rest. It's not hard. Okay? Okay? So exercising the concepts is not hard, I've told you. But, for the exam and so forth, you need to understand what's going on. So I might go through this again next time. Okay? My key controller, again, I set myself as a key listener to the shuttle component. And this is my preset X value and my preset Y value, okay, that I will take the shuttle. So when I get the character, I get a key event. In the mouse click case, we didn't even look at the mouse event. But we could have looked at it and found the X and Y coordinates. Okay? And in the case of the key event, we had to look at the event to see whether I am the X character or the Y character. And there's a method here to go and find the X coordinate, or to find the type character, and you can then go do a little switch to figure out the X or Y and do the program. Okay? I can also distinguish between key pressed and key released rather than just key typed. Okay? So key typed, key pressed together form a key type. Okay? And I just chose them. And I just do nothing if these two methods. Okay? Questions? My composer. So now I create an observable plotted shuttle, which is a subclass of plotted shuttle, a plotted shuttle. I create my view as I just type it as a listener to this particular object. I add the view as a listener to the plotted shuttle. Okay, my listener model view interaction relationship here, and I could also add all components of this plotted shuttle as listeners. I could make my view a listener also of all of the components of the model, but in this case we don't have to. But in your example, I told you earlier that your view will be listening to not only the top level model, but all of its subcomponent models also. Okay, it'll have to know when an avatar changed, if the text changed. So it'll have to listen to all of those things, not just the top level scene object. Okay? But in our case,
we are not changing any of the subcomponents. So we'll just go and make it a listener of only the top level model. I create my mouse listener, passing to it the component, the view, because the view is a component. I create the plotted shuttle controller, passing to it also the component, so that it can listen to these events. Then I create my frame. I add my view to the frame, which again sounds wrong. How do you add a view to a frame? But that's what you have to do. Okay? And we make it set visible. And I also create the object editor user interface to have both user interfaces up. Okay?
What in the podcast?
Sorry?
What in the podcast?
How did I type my view here?
I'm like, well, like, if it doesn't have a map that corresponds to that, it will automatically use that, right?
Hang on.
View extends, apply shuttle view extends view.
Yeah.
View extends component. So view is a component, and that should work even if you don't cast it as a component.
Right.
No, but I went and stored this as a property change listener.
Yes.
Property change listener is not a component.
Oh, there we go.
Okay? And I don't know whether I followed my own rule or not to create a separate interface for the view. Okay, that has all of the implemented things, and I might not have. Okay. Yeah.
Why do you have to say set visible true?
If you don't say set visible true, it won't be displayed. And we went through it last time. Just listen to the recordings. Why it's more efficient to do it that way? Because you want to create all the components first, and then go and set them view at all. Okay.